Hello, my name is John Gebara, and this is a presentation on the Astronomy app that I built for my CSE 330 mobile app development final project for Phase 1 and Phase 2, and this was made in spring 2020. The project idea was to have an astronomy-related app where the user can get real-time relevant information like date, day length, solar noon, both moon and sun, distance, azimuth, altitude, rise, set, and the moon's current parallactic angle. The main components for this app is to use the user's current location to deliver specified information, have the astronomical information be diverse enough to satisfy both beginners and intermediates, have the user save their history to compare with past and present results, while still being capable of being used by anyone and anywhere in the world and still produce proper results. The app also will have a page for the user to show and display their personal information, and this will include using core data to save the information that was received for the specific time and place the user accesses the app. For the class diagram, it is a little bit overwhelming, but it's important to see how these different aspects correlate to one another and how they work together to produce the fully functioning app. So we're going to go over each component and their primary responsibility. So for the view controller, the primary responsibility would be to get the user's current location, specifically their latitude and longitude. From there, we're going to move on to the astronomy table view controller, where we send over the latitude and longitude and have the JSON Web Astronomy API process this information and return the specified information that the user requests for that current date at that current location. From there, the user has the option to either save or view their past history. So we're going to move on to the history view controller, which has the primary purpose of organizing all the saved history in table view, and they are sorted by the date that the app has been used and saved. So from there, we can select an instance of the saved data through the astronomy custom table view cell, and we will move on to the old info view controller, which will show the info from that specific instance, date, latitude, and longitude, as well as the old corresponding information, and format it in the same format that the user originally saw from the astronomy table view controller. From there, we're going to backtrack to the pre-account view controller, where the user can put their personal information as well as a profile picture that they can select from either the camera roll or the photo library. This is the MVC diagram with the view, controller, and model. So the view takes user input from the table view and the buttons. It reacts to user interaction. It displays the table view of astronomy information and displays the user's location on a map view with their latitude and longitude. The view and controller communicate with each other through user updates from the controller to the view, which updates the display with the current view, updates the astronomy table view, as well as the table view data source methods and the table view sulfur row at index path. Now, the view interacts with the controller with user actions, like user interactions with the button, the view navigation controls, the view table view cells, the swipe to delete table view cell or cells, table view delegate methods, and table view did select row at index. Now for the controller, I included all the view controllers that I used throughout the project. And the controller stores astronomy information with core data, retrieves astronomy information from core data, sends incoming astronomy information to core data for storage on the device, handles user interaction, segues specific information to and from different view controllers, takes information from the model and sends the updates to the view, connects the custom table view cell class to the table view data source methods, and converts NS data to UI images and back. Now the controller interacts with the model through updates like saving new astronomy information, saving new locations for the user, and saving and deleting astronomy information. Now, the model interacts with the controller with notifications like how it returns stored astronomy information or returns the failure to store astronomy information, as well as location information has changed and astronomy information has been officially saved and deleted. Now, for the model, we have the class for the astronomy, the fetch results, which stores the astronomy objects, the core data storage for the information retrieved from the JSON web API, and it provides real-time updates through deleted or saved information in core data, provides file storage and manipulation, interaction with the API, and interaction with controllers through objects obtained through JSON web API calls to the core data database, and translates core data into Swift and object-related data. For the capabilities and limitations of the Astronomy app, I'm going to start with the limitations. And the primary limitation is without the user's current location, the app will automatically default to the ASU Tempe location. Another small drawback is that the information is not kept through the account, but the information is stored with core data on the actual device. Another small limitation that I face is the API limitation, where it can only be called 500 times a day for non-commercial purposes. Anything more, or if I choose to use it for commercial purposes, I would have to upgrade my membership plan. Now for the capabilities of this app, it delivers useful real-time information to the user, and while displaying the information, there's also a map that shows the user's current location. Another capability of this app is that it allows the user to save current and past history on the device, as well as personal data in the form of an account. Another amazing capability of this app is that it allows the user to pick and choose the specific information that they want to store. For example, if they use the app today, but they didn't want to save the information, they don't have to. For example, if they used it tomorrow and they wanted to save that specific information, they can choose to save it, or they cannot, and they can delete it later if they deem that it's not worth keeping. The lessons learned from working on this project would be to have more than one method of receiving location from the user. One possibility would be to experiment with implementing a way that the user could input coordinates to view astronomical information from that specified location. And the skills learned would be location-based services, map view, JSON web API usage, core data, MVC architecture, UI image picker view, table view, geocoding, UML, and UI design. Some suggestions for improvements would be to have the concept fully laid out before attempting the execution, have classmates test out each other's apps, implement one function at a time and make sure that that function is fully functioning before moving on to the next, explore more than what was introduced within the course, start early and work consistent either through a schedule or preset plan. Don't be afraid to ask for help or ask questions, and have your idea be something you're passionate about. It will be so much more fun and enjoyable and so much easier. Lastly, I just wanted to go over the main views that the user will see throughout using the app. First is the main page where the user can get the astronomy information by pressing Get Astronomy Location, view their history, and view or enter their user information. Next is the user informations page. Before anything has been inputted, this is the page that the user will see, just an empty, uninitialized user information page. For me, I entered my information, which was my name, my email, and the city that I live in, which is where I used the app most of the time. And I uploaded a photo from my photo gallery. When I left this view, the information was still in the text box and my image was still as the UI image view because these are saved on the device as the user defaults. Next, when the user presses Get Astronomy Location, this is the view that will greet them. We have a map view which shows the current location of the user, which was my home, that's my location, and all the information from using the JSON Web Astronomy API source for the current day at my current latitude and longitude. As you can see here, we have the sunrise, sunset, solar noon, day length, sun altitude, sun distance, sun azimuth, moonrise, moonset, moon altitude, moon distance, moon azimuth, and moon parallactic angle. And the user is granted the option to either save this information or view their history, or both. If they decide to view the history, they will be greeted by the History View Controller, which is the table view of all the past saved histories. And for me, I chose the option that I currently saved, which was today's. And when I click on it, I get the Old Information View Controller, which shows me the information in the same format that I saw from originally retrieving the information. Thank you so much for all your time and consideration. It was genuinely a pleasure making this project, and I learned so much just about Swift, about UI, about MVC, about everything from this course, and hopefully I get to progress in my knowledge with either another course or individually because it really was a pleasure. Thank you for an amazing year.